Tonight, for our demo, Anthony Harris is going to do basic tool. A couple months ago, I went up to Kansas City and watched him do a demo. He knows what he's doing. So we'll watch him tonight and see what he can teach us. Let's give him a good hand.
So what we're doing is spindle work, right? Anytime the grain runs parallel to the bed, that's a spindle. Anytime it goes across, we used to call that bowl turning, but now I guess cross turning or faceplate turning or whatever. But the key is with the bed, and you use a spindle gouge. Spindle gouge has a shallow flute. There's a lot of people I've seen who now sharpen spindle gouges like they're bowl gouges. They sweep back the sides. And I've never understood why. And I've never... Yeah, that's enough. And so, the key to this tool, the key to most of the tools, is you always hear people riding the bevel, right? Well, what I'm going to do today is I'm going to exaggerate some things. That doesn't mean you should turn this way, but I'm going to exaggerate them so that they demonstrate the use of the two hands. And what's going to be important, and if I say it wrong, it is wrong. What I'm going to be talking about is not right and left, but front and back hand, because that's what's important. And so this is pear. I turned it a little bit before I came, put a chuck tenon on it. And so I've got a back hand and I've got a front hand. The primary job of the front hand is to hold the tool down on the rest. It's not to move it. The back hand controls the angle and also causes it to move along the piece of wood. It's the back hand that does that, not the front. And what's happened is, you engineers out there, right? The bevel is an inclined plane. The rest is a fulcrum. And my back hand here has a hold of the lever. And essentially, I mean, for all practical purposes, the piece of wood is a wheel. And so what I'm doing is sliding the inclined plane along the surface of the wood. One of the first things that happens in classes is people want to move the tool with the front hand. And what will happen is they end up bouncing the tool down the wood, and you end up with very small, slight variations. But it's not about that front hand at all. It's about the back hand. And it doesn't matter which hand is in front. The job of the front hand is to hold it down, and the back hand, you see it, causes it to slide. I'm sorry? Yes, sir. One of the things that happens, if you use only the back hand to move the tool, you cannot control the depth by pressure. You can only control the depth by the angle of the bevel. If I use two hands and try to, I don't even know if I can do it anymore. I don't work that way. It's a balance. Maybe it works. It's a balancing act to try to use both hands to make it move along straight. And you never end up, it never works well. The back hand pushes the tool that direction. You cut too fast, you need another hand. What? It's a push cut. All cuts, well, I mean, in contrast to that, a pull cut. Yeah, I think the thing to say is first you learn the 5 basic cuts, and you learn them by pushing. And then you start doing new things. It's like you start with one grind on a gouge, right? And you don't have 5 different kinds of gouges. You just have one, and you practice it. And 6 months down the road, or 200 hours in, or however long you do it, then you try the next one. Okay, 5 cuts. That was one of them, by the way. The planing cut.
How many turners do you have?
That's pretty exciting. A planing cut is just that. I'm just creating a flat, clean surface. I don't think that's in a good position. Okay? The second cut, I call it an oblique cut, and I don't know that that's accurate or not, but what it boils down to is I'm going to cut across the grain. And it's the same. The hand on the front's job is to hold the tool down, and the back hand pushes forward. Doesn't matter which direction you go. Job doesn't change. The angle changes because I change the angle of the tool. Here's a nice shallow one. Even shallower. Well, I can just control that speed all the way, can't I? I can go forward and backwards. You know, one of the cuts that people have trouble with sometimes is how do you clean up the end of something, right? Well, that's the oblique cut. The tool always cuts the direction the bevel points. If you make a little mark here on the heel and another on the toe and you draw a line between it, that's the direction the tool cuts. And so if I want to cut straight across, I need to point my bevel straight across. And nothing else really changes. You just got to push the tool that direction. It's moving that way, right? But you push it that way because that's what keeps the bevel on the wood and it slides. That's the oblique cut. The cove, okay? The cove is the first one where we're going to actually cut a curved surface. And it starts just like I did this, right? Bevel pointed straight across. I'm going to do the other side first. It's all right. But the bevel still points straight across. And the handle coming back is what causes the curved cut. And the front end, the bevel, it just slides on the piece of wood. You never go up the other side. Anything that keeps the bevel on the surface that you just cut, that's what we're doing. Fourth cut, the bead. The bead is the exact opposite of a cove. But it's still the same in that the backhand causes the bevel to slide on the surface that you just cut. What's happened? I just got a... Oh my. Same difference though. My job is to keep the edge of the tool at the same place on the surface of the wood. The bevel slides along behind on the surface that has just been cut. This is what I meant by a caricature. Obviously nobody really does this unless they're showing off or something. I don't know how to do that. Okay? The fifth cut is a peeling cut. Now everybody knows what this is. parting tool. That's a peeling cut right there. I peeled the wood off. You do it with almost any tool. Ride the bevel. I'll do it with a gouge too, but I'm never excited about this. Okay, and the reason it works is this flat surface, just riding on the wood. Okay, so let's think for a minute. How you get a cut started? Can you show the top one? Oh, it's over there, okay. I have touched the heel, the back of the bevel, to the wood. It's pointed the direction I'm going, and I raise the back end up till I just see a little bit of dust coming off of it. There it is, and now I push forward. If I continue to push, after I get that little bit of dust, I'm going to cut too deep. If I use both hands and start cutting then, what will happen is I will control the depth of cut by pulling back on this other hand. And so all I want to do is hold down on the tool until I see that little bit of fuzz and then push it forward. I control the depth of cut by where I put the handle. Here's shallow, here's deep, shallow, deep, and it's all the back hand that does it. Any tool that has a, boy, I'm scared of this now. Here we go. Let's try this. Can we do it with a skew? Yes. You hear that? What's happened is I have a little hard place in the wood and it didn't cut quite as deep, and so the next time it comes around it's underneath the bevel and pushes it out a little, and it gets bigger and bigger every time it goes around at 3,200 RPM now. I figured I'd just leave it running fast. I can't go any faster. You can do it in a bowl. You can do it anything that uses a bevel. And carbide users don't need to apply. Okay? So the oblique cut. Doesn't matter what kind of tool you use, got a bevel. The only thing you can't cut with the skew is the cove. And even a cove you can do, but it's not pretty. I don't know what will happen here either. Let's see. Uh-oh. Well, not going to win any prizes for pretty. Okay? Let's do it again, real slow. The planing cut's pretty straightforward. It's alive! Okay. I can't hear.
His elbow is just at the right height.
Yeah, it is. The bead in the cove, one of the things I said was it's the handle going around that creates the shape, right? A lot of people, when they start out with their tool pointed straight ahead and they try to make a bead like that. And the problem with it is, I mean, obviously you can make something neat-ish, but the problem is you never get past, what is that, about 45? Whatever the angle on your bevel is, right? I've also seen people do this. Let's see if I can do it. I'm going to use, can you see it? The side of the tool right here. Pretty exciting. And the reason people do these things is because they don't want to do this. See how I'm pointed that direction? I'm going to cut that direction, right? Bring my tool up. There it is, starting to cut. Look what my handle does as I go around the bead. Nobody wants to do that. Go the other direction too. The other thing that happens is the tool goes on its side. All right, I start out pretty much flued up, and when I finish, I'm over here. The reason you do that is not to make a curve, but to keep it from catching. I use just below the point, wherever the point is, just, I don't know, I don't know how to say it. 3 degrees past the point, that's the part I'm going to use. And I keep that part on the wood all the way around. That's what turning the tool on its side achieves for me. The same part of the tool cuts the whole time. When you convince people that they have to turn the push the tool sideways, what they'll do is this. You notice I turned it off, right? They'll do this.
Yeah.
And it just scares me. So, there's the tool. It's actually not pointed straight ahead, it's pointed over about that angle. But when I finish the cut, it points straight ahead. This is like scooping ice cream. It's all about where you keep the flute. We got all the time in the world. All right, I don't know what more to say about that. I can do it once more. Is there a question about what the flute does or what the bevel does? Okay. Tool always cuts where the bevel points. You create curved surfaces by moving the handle. You keep it from catching by keeping the same part of the tool cutting the whole time. You notice there's no hurry, right? As long as there's something behind the bevel, I can take all day long. Very end of this cut, I bring the edge of the handle up. What that does is it brings this vertical, real skinny part into the cut, and I can make it fully 90 degrees. Well, that's enough of that. You know you're not supposed to cut something off. It's tailstock engaged. So when you're cutting the end, the problem is always how do you cause or not permit the tool to skate sideways. I'm going to clean this end, right? And so you see what I did? I put my tool at 45-degree angle, and now in order for the tool to skate, it's not easy. This will solves the problem. Always have to cut the end off of something you use a parting tool on. Parting tool is a nasty tool. It tears fibers on the sides.
Did you have the flute parallel?
When? Just then?
Uh-huh.
The flute was same as the flat surface. Oh, you mean vertical? I don't understand.
The flute pointing at like 3 o'clock, or?
The flute is pointed real close, probably about 2:48, I think. Yeah.
Is that military time? Or?
That's good.
Make it like shades?
Let's see what happens here. Oh, it's safe, right? That end is safe as long as the heel of my flute touches it. And I start bringing it out, and then I can cut. A lot of different ways to hollow. Who has used a ring tool or a hook tool to hollow? Okay. No? Yeah. Not going to be able to do it. I'm using the bottom wing. Using it as a scraper. I don't like it. It's getting hot.
Let's just say those shavings are hot.
Say what?
Those shavings are hot.
Yeah.
I can see them coming up on your camera.
Oh, you guys know you're not supposed to move this when it's running.
Yeah.
Okay. So here's the, oh, one more cut, I'm sorry. There we go. Okay, 1/2 inch round nose scraper. The leading edge of it here, the side of it here, that's just because of the way I sharpen it. I make sure there's no change in the curve. I don't want a corner, and so over time that's the way my tools end up looking. What I do is put it exactly in the center, and the tool cuts. And what it does is it just cuts a little divot. If you think of the very, very center as just like what this point here is my finger, if you bring the tool up and hit high, it won't cut because that point touches the flat here, right? If you let the tool be too low, what it'll do is cut a ring around the point, and it'll leave the point. Same thing happens if you bring it too far to the left. It'll just cut a ring. If you bring it to the right, it'll go up and down. It's real exciting if you press very hard, okay. You have to keep firm pressure on the tool, but if you have to push hard, then something's going wrong. The tool likes to cut when you hit the center. So when you press into the center, you get a little bitty divot, and then you go sideways. And side grain's easy to cut. It's only that end grain that's hard, and so you have to find the center. And what happens is, when you get close, can you see my tool move? But when you hit it, it just cuts a little divot. It's moving, it's moving. There it is, okay? Side grain's easy to cut. That nasty end grain, that's the problem. Who here's done hollow forms? Got a little nib in the middle? That's what this is.